Okay, so let's derive the angle sum and difference formulas. So angle sum or difference formulas. These are lumped into the same thing because they're just two different applications of the same formulas. So for the sum, we have sine alpha cosine beta plus cosine alpha sine beta. And for the difference, we have sine alpha cosine beta minus cosine alpha sine beta. And for cosine, for the sum, we have cosine alpha cosine beta minus sine alpha sine beta. And for the difference, we have cosine alpha cosine beta plus sine alpha sine beta. And for tangent, we have, for the sum, tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. And for the difference, we have tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Okay, so the way we will derive the sine and cosine identities is using a diagram, and we'll actually just generalize it. So we'll draw alpha and beta to be positive angles, but then the formula will work if we just replace beta with a negative angle, and we'll produce the difference identities from that. And then we can derive the tangent identities from the sine and cosine identities. So let's start with a right triangle with angle alpha, and then we're going to attach another right triangle to that with angle beta, and let's just complete the rectangle. And then we will define the hypotenuse of the second triangle to be 1. We can define this object however we want. So if we just define this right triangle with a hypotenuse 1, with an angle beta, and then attach to it a triangle with angle alpha, then we can solve for the remaining quantities to get the angle identities. So because this total angle is alpha plus beta, then the angle over here is also alpha plus beta. So because this triangle on the left has angle alpha plus beta and hypotenuse 1, then the opposite side here, that's going to be sine of alpha plus beta, and the side adjacent to the angle is going to be cosine of alpha plus beta. So if we can find the side lengths of this triangle, we have our formulas. So the side length sine alpha plus beta, that's the left side of our rectangle, is going to be the same as the right side of the rectangle. So if we can find both of these sides and add them up, then that will equal sine alpha plus beta. So first, let's find the hypotenuse of this triangle on the bottom, and then we can find the vertical side. So the hypotenuse, well, this is the component of the triangle in the middle adjacent to the angle beta, and the hypotenuse is 1. So this adjacent side, that is cosine of beta. And we know that the bottom of this triangle is the top of this triangle, so this side is cosine beta. And so the side opposite to this angle alpha is the hypotenuse times sine of alpha. Now for this triangle in the upper right, since this angle here is the complement of alpha, and then we have a 90-degree angle here, then on the other side of that, that's going to be alpha as well. And so we want the vertical here, which is adjacent to the angle alpha. And so we just need to find the hypotenuse of this triangle. Well, that's going to be the vertical of this same triangle here. So that's going to be sine of beta. Okay, so the adjacent is going to be the hypotenuse times the cosine of alpha. And so we have just showed that the side length on the left, which is sine of alpha plus beta, so sine alpha plus beta is, and just writing them in the right order in order to appear the same as our formula, we have sine alpha cosine beta plus cosine alpha sine beta. Now, this other side length, cosine alpha plus beta, is going to be what remains from this bottom side when we subtract whatever this side length is on the top of the triangle on the upper right. So first let's find the bottom side. Well, that's going to be the adjacent component of this lower triangle. So that's going to be the hypotenuse times the cosine of alpha. And then the top side for this triangle in the upper right, that's going to be the opposite component of alpha. So that's going to be the sine of beta times sine of alpha. The hypotenuse, sine beta, times sine of alpha. So the top side here is sine beta, sine alpha. The bottom side here is cosine beta, cosine alpha. And so cosine alpha plus beta is what remains when we subtract sine beta, sine alpha from cosine beta, cosine alpha. So just writing everything in the right order so that it appears the same as our formula, we have cosine alpha, cosine beta minus sine alpha, sine beta. So for the angle difference identities, we're going to use the same formula, but we're just going to replace beta with minus beta. So wherever we have beta, we're just going to replace it with minus beta. So because cosine is an even function, then the cosine of the negative of an angle is the same thing as as the cosine of that angle. But sine is an odd function, and so sine of the negative of an angle is the negative of the sine of the angle. And so we have the difference identity for sine, and we'll do the same thing for cosine. So eliminating the sine of the angle for cosine, but flipping the sign for the sine function. Okay, so now we have the angle, sum, and difference formulas for sine and cosine, which we can write more compactly just using plus or minus. So the one for cosine is going to be minus or plus, because the minus sign corresponds to if we have alpha plus beta, and the plus sign corresponds to if we have alpha minus beta. So it just flips the sign. An easy way to remember these is this sort of jingle: sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So when we say sine here, we mean S-I-G-N. So sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, so for the tangent identity, and we'll just go ahead and go straight to the plus or minus case. Well, that's going to be sine of alpha plus or minus beta over cosine of alpha plus or minus beta. And we have the formulas for these, so we'll substitute them in. So if we want to have this in terms of the tangents of alpha and beta, just like our sine and cosine for the angle, sum, or difference, we're in terms of the sines and cosines of the original angles alpha and beta. If maybe it's easier to take the tangent of both of the angles instead of the sum or the difference, then we'd like to have it in terms of that instead. So we want to change all our terms to be in terms of tangent instead of sine or cosine. So the first thing we can address is sine alpha. We want to divide that by cosine alpha in order to get tangent of alpha. And so we just need to do the same thing on the top and the bottom in order to not change this formula. Assuming cosine is not 0, but if cosine was 0, then that would mean that the angle is plus or minus 90 degrees, in which we could just apply a shift of our tangent function, and that's going to be a nice number that we can easily shift. So divide through on the top by cosine alpha. When we divide the first term by cosine alpha, we get tangent alpha here. For the second term, that gets rid of the cosine alpha. And on the bottom, dividing through by cosine alpha, for the first term, that gets rid of the cosine alpha. And for the second term, the sine alpha gets divided by cosine alpha, so we have tangent alpha. Yep, those should be sine beta. So now we can apply a second step to turn the sine betas into tangent betas. So we're going to divide through on the top and bottom by 1 over cosine beta. Again, with the argument that beta is not 90 degrees. So if we divide the first term by cosine beta, it eliminates the cosine beta. And for the second term, that turns it into tangent beta. And then on the bottom, for the first term, that gets cosine beta over cosine beta is 1. And then the sine beta turns into tangent beta. And that's all. Thanks for watching. I'll do another video on the double and half angle identities and the power reduction identity, which are going to be related to these sum and difference identities. So don't forget to like and subscribe and leave a comment. Let me know what else you'd like to see.